This is the first of 3 videos on the most advanced application of Newton's basic laws that we'll cover. What happens when gravity is pulling down on an object and there's another force pulling up on that object that changes with the object's velocity? This occurs all the time in the real world. Skydiving is an example you can think of. Here we have a block sliding down a slope with a flag on top leading to a drag force. And we'll cover a relatively simple example of problems involving drag force, where the drag force changes linearly with the velocity of the object. That's the k times v of t term. Our goal is to come up with the formula for v of t, how the velocity of the object changes over time. Let's first state what we know. The net force on this object is F sub g, which we'll make positive here since it's leading to positive velocity, minus k times v of t. The ma on the other side of this equation we'll write here as m times dv of t over d of t. The derivative of the velocity is the acceleration. We're first going to write the answer, what the actual formula for v of t is, and later explain why it makes sense. As you can see here, it is f sub g over the constant k from above times the quantity 1 minus e to the negative quantity t over k times m. This formula should initially seem like it comes out of nowhere, but let's think about the intuition. At time t of 0, e to the negative t over k times m is going to be 1, since e to the 0 is 1. And that means that v of t is going to be 0. That makes sense. The object starts at rest. As t goes to infinity, e to the negative t over k times m is going to go to 0. And that means that the object's velocity is going to go to f sub g over k. Now that turns out to be a really key quantity. This is the terminal velocity of the object. Now, let's see why this makes sense as an expression for the terminal velocity. Going back to our original differential equation, note that saying v of t equals the terminal velocity is equivalent to saying that dv over dt, the acceleration, is 0. This makes perfect sense. If the object keeps falling, the drag force keeps increasing, and eventually acceleration goes to 0. So that's the intuition for the formula for velocity in the presence of drag force, and the intuition for the formula for the terminal velocity of an object in the presence of drag force.